Hello and welcome to this video live from Warsaw, Poland, where I am here at CD Projekt RED's headquarters, and I just saw the Witcher 4 demo running on a PlayStation 5, and it was mighty impressive. And I'm joined by these fine gentlemen here today from CD Projekt RED and Epic to talk about it. And if you would, please introduce yourselves.
Hi, I'm Charles Tremblay. I'm the VP of Technology. I pretty much oversee all tech development across the company.
Hey, I'm Jakub Knapik. I'm the VP of Art and Global Art Director. I oversee all the art, and I had a pleasure to work with Lucian Więcek, Art Director of The Witcher 4, and obviously the content team on the Silver demo, lighting and look development.
I'm Kevin. I lead one of the rendering teams at Epic. On this demo we did together, I was part of a lot of the rendering stuff and performance aspect.
Hey, I'm Kajetan Kapuściński. I'm a cinematic director at CD Projekt RED. I was responsible for directing scenes and whole flow of this technical demo that you've seen, and also I was the one playing it live in Orlando during Unreal Fest.
Hi, I'm Jan Hermanowicz. I'm engineering production manager at CDPR, and I was the main producer and the dev owner of Project Silver. Oh, that's the code name for this. Now it's spilled.
I'll edit that out in post. That actually gets into my first question, was what is the timeline of this demo and the cooperation between Epic and CDPR look like? Because we had an announcement a number of years ago that you would be moving on from RedEngine to Unreal. So when is like the beginning of the cooperation and the genesis of this demo? When is that, and what did that look like?
Okay, I think I can take this question maybe together with Charles, because it's like two questions in one. So in general, our collaboration is pretty much since we announced that we are switching engine, a little bit before that, right? So that will be about 3 years by now.
2022.
Yeah, so 3 years by now, and this is pretty much as long as we collaborate with Epic Games. When it comes to this particular demo, projects like that have different stages, so it's sometimes hard to draw a definite line between like a pre-production or ideation phase and the actual production and pushing the content forward. But let's say this is a relatively fresh thing that we started working somewhere last year.
Mm-hmm. So obviously we're joined also by you from Epic today. But what was internally at CDPR in 2022, what was the impetus to actually want to move over to Unreal Engine? Because we see an Unreal Engine 5 demo, it was a big part of Unreal Fest, but you had internally used your own tech for a long period of time. So what was like the core factors in switching over to Unreal?
Yeah, it's a very good question. I get it often. And I always preface this with one statement, is that because I don't want people to think that the tech that we had was problematic or like, it's shit or something like that. No, actually, we're super proud of what we achieved for Cyberpunk. I think even today it's a statement of what we achieved, and we scale very well. But that being said, when we started the new project, The Witcher, the company, we wanted to be more as a multi-production company, and our technology was not very well made for that. It was one project at a time, and then you just put the gameplay down and then you move on. Not very well made to have multi-project in the same time. Second thing is we also want to extend to multiplayer experience, and once again our tech is a single player game, so it was very complicated to move on with this. So we decided to partner with Epic now to follow the company strategy. So yeah, this is where we are now.
Mm-hmm. Okay, so we specifically just saw that running on PlayStation 5, and I would say that it's actually quite against the grain from what CDPR had done in the past, where we would see, for example, The Witcher 3, or even I saw it multiple times at Gamescom, the wonderful PC CP2077 demos, but here we're seeing it demoed on PlayStation 5 at 60 FPS, so a 60 FPS target. So why show it off on PS5 first? Why target 60 FPS?
I think that when we started the collaboration, we have super high ambition for this project, and we always, as you said, we always do PC and we push, and then we try to scale down. But then we had so many problems in the past that we tried to see, okay, this time around we really want to be more console first development, right? So and then we worked with Unreal with our partner, and then we saw the challenge to realize the ambition that to make what we want as 60 FPS on PS5 would be, there would be work. And this is why we started to talk to figure out what needs to be done with the technology. And we also decided, okay, we need to have all those things that needs to be developed. Where we go from there, it's hard to say, but right now we really wanted to focus on what does it mean to make this ambition on a console. And we have all our other projects at 60 FPS, and we really wanted to also to aim for 60 FPS once again, and not go back to 30 FPS or something like that.
Yeah, and it was a mutually shared ambition together with Epic, right? So when we started talking about it, that I think that was literally like the first pillar we established together, that this is gonna be a console 60 FPS
no
demo.
fake console 60 FPS, fit in memory.
Constrained by platform, pretty much.
Yeah, it was a really good opportunity for the engine as well to use this as a demo and really showcase that 60 FPS on a base console is totally achievable with all the features that we have.
Yeah, that's quite different than the Matrix demo, for example, which was targeting 30 FPS and was the last time we saw, at least on the console side of things, a hardware ray tracing demo from Epic itself. But still, you're talking about 60 FPS versus 30. That's a whole bunch of frame time. Do you see this as a challenge or a limitation? Like, how do you view it? Because strictly adhering to that in an open world it's a mighty big challenge. Like, how do you view it?
Yeah, so I think that at this stage we are perfectly aware that we still have a lot of work ahead of us, right? So this is a tech demo. There is not the whole gameplay loop is implemented. There's no combat. There's a lot of things that doesn't work. But still, the ambition is set. So this is where we want to aim, and we'll be damned if we don't try to get this game in performance. It's too early to say, if we manage to nail it, but we'll work as hard as we can to make it for sure.
Mm-hmm. At least based upon the base rendering tech, it seems like it's at least there to get that part of it at 60 for the most part, because the demo is incredibly fluid. As I said, when we did the DF Direct on this, it doesn't drop a single frame. That is something you usually see in a demo like this. For example, the Matrix demo could drop frames if you go back in time to our coverage of it back then. So this was mighty impressive from that aspect. From Epic as well as from your side, Hardware Lumen to this point has been on consoles other than on Fortnite's most recent season. That was a new thing. Been limited to 30 FPS ambitions typically. So what were the big roadblockers on a console like the PS5 from getting Hardware Lumen up to within 16.6 milliseconds?
I mean, obviously it comes down to performance, right? And optimizations on both the GPU side and the CPU side. So on the CPU, there's been a ton of work on optimizing away a bunch of the cost on the critical path, on the render thread. So, multi-threading things, removing all sync points that we don't need, allowing all types of primitives to actually time slice and not only landscape or something like that. That's for the dynamic parts. On the GPU, obviously tracing cost needs to be kept low. So, having good proxies, streaming in the right amount of stuff in the vicinity. These things just, making that work out of the box is core to that 60 FPS.
Mm-hmm. So why, though, want to use hardware ray tracing when there's already a software path that does target 60, for example?
Right. So the software Lumen path has a lot of limitations, things we simply cannot get away from, no matter kind of how hard we try. The distance field approximation or the representation is effectively static. Right, and the more dynamic worlds we build, we want that to also be part of the ray tracing scene. So, using hardware ray tracing for that is much better. Quality-wise, we can get a much better representation with ray tracing than we can with distance fields. So it's generally it is also kind of the future. We see that in hardware coming out as well, that we're going to focus on that. So we are focusing on hardware Lumen for sure. And consider software Lumen to be hopefully a thing of the past.
Mm-hmm.
And also, I think if I may add, there's looking from the Witcher point of view, this game will have dynamic day-night cycle. So when you look at it from this point of view, you need to secure the environments lighting-wise for all light angles. And it's an open world game. So you need to make sure that the way you make content will work and it will not light leak in all the situations. Hardware ray traced Lumen is just much better for securing your walls to not leak lumen inside, or just like Kevin said, you actually can move trees and have a proper occlusion. So for us, it was like, okay, If we would go with software, we would have a lot of limitations, that's one, but it's a different way of how you set up the environment, like from the content point of view for both modes, and that will actually kill us from the production point of view. So looking from this point of view, there was just one big challenge. We just need to do it on the tech side, because it would literally kill us on the production side later on. Otherwise, we'd have to change the design of the game.
Yeah, I think actually that's a pretty good point. If you do Software Lumen on one platform, but you intend on scaling that up to Hardware Lumen on another platform, like working with both is problematic. Like you want to have the one representation. It's much better.
Yeah, I mean, it's as much as it would be great because we love to see hardware utilized everywhere, you're kind of locked into something from a QA perspective, an artistic perspective. You can't just be doing everything as much as it would be great. But from your perspective, primarily coming from the tech artist direction, what is it like to work on a title then in the future where you have access to real-time global illumination and real-time reflections for the first time? Because in Cyberpunk you had that, but it was only on the PC SKU primarily. And here it's going to be the baseline, presumably.
Yeah.
So like, what is that like from your perspective?
Well, we altered the game on PC, Cyberpunk.
Yeah,
so actually, it was a bit of an issue resolving, finding the middle ground artistically so that it works both on console and high-end PC, right? Here we can actually, with this approach, we can alter the game once, and we make sure that it's pretty much visually similar. It just gets better, but it's similar visually across all the platforms. That's the difference. We can ensure that our direction is consistent across all the platforms. While in PC, you could say that it is slightly different, look-wise, between the lowest grade and the highest grade platform, right? So that's the difference.
Mm-hmm. And also for like cinematic authoring, using Lumen for the first time in cinematics, could you explain it, like what it was like for you?
I'm not super technical, so probably majority of questions will go to the others. But yeah, like how we can now work on cinematics using the tools that we are provided with Epic and the tools that we are co-developing with them. Like it opens up a lot of possibilities to actually have this creative freedom to be able to create scenes like you've seen at the beginning of our demo. And this is, for me as a content creator, not really on the tech art side. It's great. It's just, liberating in many ways, and that's super cool. And yeah, like Kuba probably can explain more about the technical side of it.
Yeah, well, actually, there are many more aspects to the look apart from Lumen that we actually introduced in this demo that actually contribute to like the more cinematic experience of the cameras, like lens simulation, film simulation, ACES, all that stuff that we also added while working on the technology for The Witcher, right? So all that contributes to a slightly more, effortless, I guess I can call it effortless approach to scenes.
Mm-hmm. You could already see, I know you just talked about the other aspects of cinematography there, but one thing that struck me in the demo is when the coin hits the ground and it flashes time of day, like immediately. And that's something that would be a great struggle to do using any form of baked lighting, let alone have the quality be maintained after the flash. And it doesn't drop a frame during that flash too. It's another thing to comment on. It's pretty impressive. So we're looking at the demo. It's got the cinematic aspects. It's got you walking through the town, but it's also a large open world, which the Witcher games are known for. For this demo, how were objects such as trees, rocks, and the town itself placed within the terrain, and how was the terrain generated actually for this demo?
So the pipeline we use for this is actually the pipeline we are using for the main game, right? So there's a little bit of let's say there's ideation and then the actual landscape creation within DCC tools. So we do the first pass outside of engine, and then we import that height map for the landscape into the engine, and then we do the rest of the sculpting actually in Unreal Engine there. So this is purely when it comes to the terrain layer, right? Of course, the final picture that you see is a layered picture. So on top of the landscape itself, there is plenty of meshes. There is some additional rock formations. There's trees and all that stuff. There is a procedural PCG layer, pretty much, right? But the pure height map, pure terrain. This is the pipeline that we are using there.
Mm-hmm. And that it also goes over to like the small stuff that's scattered on the ground. That is the PCG. PCG.
Yes. So that is a runtime PCG. I I hope it's not too much of a simplification, but we can say effectively we replace the autograss with the runtime GPU based PCG, and we use that for all the smaller what you would use autograss normally for, right? So all the small debris, trash in a case of the town, right? Grass and stuff like that.
When it comes to making those trees, though, that was probably after the getting to Hardware Lumen to 60, I'd say like the largest and most visually impressive thing of the demo is the density of the trees, the way they look, the way they scale. From an artist perspective, though, we kind of already know a little bit about how it works. We can talk to that in a second. Is this the biggest change you've seen in a long time of making like vegetation in games? Because it's been about these alpha cutout cards since I was a child.
Absolutely. I think that plus PCG, that combo, I think this is a killer combo. Because creating a foliage big trees is one problem, creating a small foliage is a second problem. I think with this demo we tried to combine those two techniques into creating a foliage. And actually the trees, just like Kevin someone highlighted already, was our biggest concern because of how you alpha sort or how you create illumination and then how you actually move the trees around. Because if you have a static trees, that's one problem. That's a pretty approachable problem even before this demo. But having a movable trees, I remember I was in a big doubt. Like I had this discussion with Lucian, the art director. I said, Lucian, you can have good lighting or moving trees. It's hard to have both. Really, it was like 2 years ago, that was our discussion internally, pretty common. And so we tried to actually challenge that. And there was a lot of effort coming from both CDPR tech teams and Epic tech teams to resolve that problem. And yeah, Kevin, you can pick it up actually, but that was by far the biggest change and concern we had when it comes to The Witcher.
Yeah, I mean, as you said, alpha cutout cards has been the way for many, many years. But I mean, it just doesn't really cut it. It's flat, right? So it can look good from a certain angle, but not every angle. Shadows might be problematic as well. So just throwing geometry at it is kind of the only way to make it real volumetric, right?
Exactly, and it opens new possibilities for artists, right? So, for example, those like pine needles, you can see up close on the big tree that we are showcasing that we're really zooming in on the demo. That is like a perfect case for geometry, right? You can actually model those pines, and doing this based on cards is a bit like probably like slap through 3, maybe 4 cards together to achieve this effect, right? Of course, it requires some change of thinking within like the foliage artist, let's say, because now the things that were, for example, like very thin, very ephemeric kind, you have this kind of plant, right? So how do you actually can you model this? How do you model this, right? But in general, the benefit and the possibilities absolutely outweighed whatever new challenges might pop with this new pipeline.
Yeah, I can already imagine that. Like, it's going to also allow different types of vegetation that you don't typically see in games to become more viable, like willow trees and things like that are actually very challenging and tend to look pretty bad in games. I already can see that in my brain.
In all fairness, the reason why we had the pine tree also is because we thought it was one of the worst case.
Yeah.
And we worked on this case for a long time. Actually, I was super stressed when we started the demo, and when we Epic guys came up, with our guys with a solution. It was like, oh my god, we got it. Also, we need to consider also the asset on disk. All the assemblies it's really good, and also the Witcher, the forest is pretty much the soul of the game. So we need to have what does it mean to have yet the new iteration of the forest for this game? It could not just be a traditional good old card system. It was not the one what we wanted to achieve. Yes,
I think it was like the one of the best days on working on this pipeline, because this pipeline we actually started working a little bit before the demo. So that was like one of our angles of collaboration even before we started work on the demo, when we looked at the table and actually it turned out that like this crazy insane amount of polygons without alpha actually runs faster than the classic cards approach, and like everybody's a bit like, oh yes, okay, there's something to it. Let's go down this path. So, yeah.
So you already have it skinned and animated as well. Do you then see this I want to talk a lot about this because I find it so fascinating. Sorry. But do you see this technique also bridging into other areas of rendering? The way Nanite's handling it, and then it's LOD'd at a distance, because right now there's similar phenomena like hair, even like long grass and things like that, like extruded triangles. Like, do you see this going into other directions in the future from Epic's perspective?
It's possible. We haven't really gotten all that far in exploring that. It's come up for discussion. Actually, the voxel idea isn't really all that new. Brian Karras, who came up with Nanite initially, has in his HPG talk a few years ago a section on voxels and how he explored, the idea of using voxels to kind of solve the geometric problem that Nanite eventually did, but at the time wasn't really a perfect fit for everything. Turns out it was actually a very good fit for foliage. So anything that might, look like foliage might actually be a contender to use this tech. It's going to be continue to be explored. If there are ways to make this better, obviously we'll take a look at that for sure.
Yeah, I'm just curious about because right now when Nanite falls back, it usually goes to the H-LOD at a distance, and that doesn't happen for trees right now, correct?
Doesn't. They're part of an instanced H-LOD. They don't bake down to anything, but that was by choice. We could have done, if you want to, you can obviously in the distance whatever you want, but yeah, in this case, no, they're always loaded. Okay,
so. That's one thing it's described in the initial demo, that they are lit, shadowed, and all these things. But how are they lit? How are they primarily lit? Like from the direct, how are they rasterized? They're not rasterized, but how are they made, lit, shadowed? How do they fit into VSM because they're not geometry? How exactly do they fit in? Because the rest of the rendering pipeline is not voxels. So how do they fit into the classic rendering pipeline here?
They actually fit in very nicely, as in the Nanite pipeline as you know it today before voxels. Part of that is essentially just replaced by the voxel path. And that same path runs for VSM. So that's also why it's kind of cheap to render into shadows in the distance, because they're just voxels. So that just works out of the box. Lighting-wise, it's regular. We just light using a directional light. There's been improvements to the shading model, foliage shading model, but in general, it fits into the ordinary pipeline quite well. On the indirect side, we have a simplified representation, which is static, so that doesn't move for performance reasons. So it scales up for sure. We could obviously make everything, model out everything in the ray tracing scene and make that all animated and everything like that, but for performance reasons, for this demo, obviously we don't.
You just talked about shadows. Another thing that the demo does show off that we don't see actually always in a lot of shipping UE5 games to date is, yes, Lumen, both specular and diffuse, but also VSMs. Some titles we've seen cut it just using normal CSMs because the expanse is too high. So how did you get VSMs performant at 60 FPS with everything else that's going on here?
There's been a lot of work for a long time on improving performance in VSM. I think in a lot of cases when people might turn it off is maybe because they have a lot of non-nanite geometry in there, because VSM is really good at rendering nanite because it can do much finer culling when it renders into those pages. Whereas if you render a non-nanite mesh, there's only one bounce. There are no clusters. There's just one big thing to render. General optimizations for sure. That's been the main point. Obviously, the settings are important as well. You can't just go with the absolute highest resolution and the highest LOD bias and everything like that. You need to make sure that your settings actually are appropriate for what you intend here. For the demo, I don't recall the exact number, but we have a very sensible setup for sure. You can see some flickering on, skin, some surface from lower resolution shadows, for example, but it works for us.
Yeah, it's impressive that it scaled though at all, because when I've ever tested UE5 on my own, it's usually one of the highest scene cost aspects. So getting there on the 60 to PS5 is impressive in its own right. Let's talk about the flawlessness of the demo in terms of frame time and frame rate, because that's another big takeaway of this, where especially on PC side of things, I'm a huge stickler for having good frame times, no hitches, very anti-stutter as I describe it always. How exactly is the demo achieving this almost perfect frame time? I know in the 60 FPS making of the Witcher 4 demo, you said you're using a specific version of triple buffering to get it essentially flawless throughout the entire demo and for camera cuts. Can you explain a bit of how it works?
So first of all, the average frame time has to be within perf, of course. I mean, that's right. So we rely on dynamic resolution to make sure that we've got a achievable 60 on every frame. And then we have the camera cuts, which is kind of the biggest enemy of this, as you alluded to. And in that case, what happens is, a camera cuts away, we lose all the history. That means also the depth for the nanite occlusion culling. So we have to re-render a lot of extra stuff. So overdraw is massive in that first frame. And typically that spikes, it can be 10 milliseconds or more. I don't know, but it can drop a frame for sure. So initially, tackling that was an optimization to prime that data so that we actually have something to cull against. That already brings that down significantly. But in a lot of cases, we're going to go above those 16.6 milliseconds anyway. But given that we don't have the super low latency mode enabled, it actually gives us quite a bit of latency, quite a bit of kind of pipelining in terms of like buffered up frames to the point where you can go above for frame time in one frame, and then if the next frame doesn't go above, you start catching up again, and you don't actually lose that frame. So essentially what that means is by the time you submit your work from the CPU to the GPU, the time that work has to finish before the next present, you can have 2-3 frames of buffer zone there, which means you can eat these hitches. For the visual aspect of this, if you looked at the demo more closely, you can see that the first frame is actually pretty good after the camera cut. And that's because we actually, with this kind of buffer, we can render 2 frames before the next present and then just discard one of them. The first one provides the history for the second one, which means that one now looks much better. So it's effectively, if we manage our frame times enough, then we can kind of get away with that.
Do you see this as something, because this was an isolated demo on a PlayStation 5 where you have complete control over how many frames are queued and all these things. Do you see this as like a user selectable option in Unreal for specific cases or something like that? Because as a PC player, if I had an option in menu that said smooth cutscenes, I would always click it, like smooth cutscenes.
So, there are 2 options here, I guess. One being the way we sync the game thread to the GPU.
Mm-hmm.
There's already options for that. You can do really low latency stuff where you sync with the present. So you just try to be as up to date as possible from your logic to your frame, so you get very little latency.
Yeah,
or
like reflex,
or you can have sync your game thread to the render thread, then to the RTGI thread. So you actually get a bit of a pipeline going, which does smooth this out. And then you can select double buffering or triple buffering if you want to have even further things piped up.
Yeah, and there's quite some work we did together also on the game thread side of things, right? So on the CPU side, right? So smooth. Like we needed both to be smoothened up, right? So on the CPU side, we offloaded as much as we could to async, right? So it can be computed over time. Unreal Animation Framework also helps a lot with that because it offloads a whole bunch of animations to the other threads, and actually you don't suffer that much from a game thread tick, right? So the frame is pretty much like the whole game frame is not waiting for all of that to finish, right? Plus streaming improvements, right? So this is a big one because we are now streaming smoothly geometry with FastGeo. In this case on this particular demo, so we are not loading a big chunks of a word, for example, right?
Mm-hmm.
Plus, another aspect of this, which I think is important to also mention, is it requires some strategizing, right? We know this particular map, same as we know the maps we are making for our open world and the content. So like when for example, is a good moment to load all of the community that is in the village, right? We can do this strategy both here and both when we do it in the game, to make sure that those things are not just like oh it happened, oh there's a hitch, right? But rather when we think is the right moment, right?
Mm-hmm.
Of course you won't be able to like predict everything and strategize everything like that, but actually like having this thought process and going through this and looking at the frames and how the entire thing lays out is an important part of this.
Mm-hmm. So you described also the FastGeo plugin there, as well as streaming improvements. But when you look at it from Epic's point of view and in Unreal, what are those typical things that you see in a UE5 project that cause a hitch when you're running through an open world? A lot of people, when you read comments underneath our YouTube videos, they're always saying like, oh, it's the SSD speed. But I don't think that's actually usually the problem. So where do you usually see, and how did this demo avoid those pitfalls, essentially?
I mean, the streaming is definitely one thing,
Okay.
and FastGeo is helping in that area. PSO hitches is another, not a problem on PS5. In general, we've got garbage collection, which is another one, and for demos, it's possible to schedule the garbage collection more intelligently. But in general, like going back to what you were saying about all these different improvements to optimize the CPU in general and streaming, like just knowing that you can have pretty much a healthy frame every time without any surprises is definitely key here. Because I mean, if you can, sometimes, there's suddenly you walked in somewhere and you just started streaming in way too much stuff and you don't have any way to mitigate that or time slice it or whatever, then you're gonna hit that eventually. So just kind of ironing out all those issues and making sure that we're in a healthy state in general is what's going to help these cases.
Exactly, and I think the process that we had here was also important, because like both sides approach this like with super open mind, and I think on the game on the CPU on the game thread side, we pretty much went through everything that happens there and asked ourselves a question: does it have to happen here, right, or can it happen on the worker threads? And of course, there are some things that there are on the game thread. Obviously, that's what it's made for, right? But we really went through a lot, checking and verifying if we can upload it to either async or just to the worker thread, right?
So this is more of a philosophical question, because it's a bit challenging, but you keep referencing back to render thread, game thread, etc. When is the point in time in the future in Unreal when we don't reference the game thread as being this like monolithic thing that we have to be afraid of about how much stuff is on it? Can it be broken up over time? That was a big part of the demo, making it async, making it parallel, the things that could be. Are we always going to be struggling against the game thread, essentially, in the future?
Well, I mean, you have to sync up somewhere at some point, but the work that has been done and has been ongoing for a while is to offload all this work from the game thread, from the render thread, from these named threads into more of a kind of a worker task, or making this async essentially. So I think if this work continues, eventually the named threads are mainly going to be there for legacy reasons, so to speak, philosophically. So that is certainly the path forward, is to just try to make use of the hardware as best as we can, and not be beholden to like an old paradigm of these particular threads.
This isn't in reference to the demo completely, but you're coming from RedEngine and you took those learnings from there. So how was the split and setup actually from game, render thread, etc. on RedEngine, and did that play an influence on what you guys are doing with UE5 now?
Okay, so yeah, it's very different because we don't really have a game thread on RedEngine. When we came from The Witcher 3, yes, we were a bit the same. So classic render thread and game thread. So when we went to Cyberpunk, we already knew that it's not going to work on to maximize the hardware for the ambition. So we did quite a lot of work when we switched to DirectX 12, and we managed to. We had also a garbage collector, so we did a lot of work to remove this. That being said, we also had all the gameplay that was multi-threaded, and it's it sounds cool, but it was very challenging because the gameplay programmers and or even the engine programmers sometimes they go from a single-threaded paradigm to a multi-threaded paradigm, and now suddenly stuff start to crash, and now you need to change your mindset how to parallelize everything. So it was quite challenging actually to make the migration. And now if I go back a bit fast forward with Unreal, this is definitely one thing that we had a long discussion and a lot of work. I think we just brushed a little bit like, FastGeo and this and that and easy. It was a lot of work with Epic and us to, analyze the frame, figure out, okay, this can be out of the game thread. This can be done differently. And I think the guys did amazing work actually. And I wish I could say months ago we were done, but it was improving continuously until the finishing line.
Yeah, and real AAA content like this is what we can use now as a basis for kind of pushing all these things.
Yeah, it does seem like a big push in the engine itself beyond what CDPR has been doing.
And I think that when you see the crowd that we have at the end, like again, I think when we started we were like very like, ooh, are we going to be able to make it? And again, with all the works from both sides, like I think we managed to nail it down. And there's still a lot to do, but
and I think what worked excellently in this case is that we use a demo as a catalyst for this work, as a actual real, as Chas mentioned, as the actual real AAA content, right? So it allowed us to discuss looking at data and less philosophically in a sense, because you can have a very academic discussion on like pros and cons on approach, or like how hard is it, or how much do you have to change, versus we just had this, like we started working this content, we look at this content, and then it streamlined the discussion, which parts are we actually attacking and which parts, for example, are not a problem, right?
Mm-hmm. So I only saw it running on PlayStation 5, UE5 scales to a lot of platforms, PC included. How do you see this technology scaling up? Like what would you do? For example, you described already like resolution is one of them. Like how would you want to scale this up if you could scale it up? This is not a promise to anyone in the audience.
This is actually tricky. We're frozen because this is actually one of the topics we're actually thinking about it. You asked previously why we start with the console. It's because, like Charles said, just like Kevin brought it, we wanted to solve certain foundations for us. It's pretty logical when you think about it. It's easier to scale up than down. And because we know that the both Lumen and all those technologies are providing us pretty consistent representation across the scale up, we knew that once we'll, set up certain foundations, both visual and technically, there's a room to scale up. Now, what it means is another question, because we're CDPR, we always like to push PCs to the limit. It's just that it's a creative process how to really use it. We know we have like a really great foundation right now on the console that we still need to push, but we'll still figure out what it means. For sure, we're going to expand all the ray tracing features forward. So, yeah.
It's another really good argument for Lumen hardware, right? Because if you start there, you can scale up easily because all the super high-end features, if you're looking at megalights or anything like that, will use that as a basis. So,
yeah, again, I don't want to go too much in details, and again, not to overpromise and stuff. But in the past, it's something that's super important for the group is that if people pay good money for their hardware, and we want them to have what the game can provide for that, right? Not like a simplified experience. So this is something we'll definitely explore, and we'll definitely make sure that the company started as a PC company, and we definitely will want to have the best experience for the PC gamer for sure. But it's too early to say what will it mean for this, for The Witcher 4.
So scaling up, but scaling down. We have an Xbox Series S out there, if you've ever heard of it. And you guys did scale, I'd say, rather gracefully in CP2077 onto the Xbox Series S. Where do you take a demo like this and get it running on something with less memory and far less GPU resources?
Well, I wish like we did a lot of work already on that, but we did not. So this is something that is next on our radar for sure. I will be, well, again, maybe, but I will say that 60 FPS will definitely be extremely challenging on the Series S. Let's just say that it's something that we need to figure out.
Okay, so second last question from me here, or maybe third last, we'll see. I come from PC, and in the past, RedEngine, for example, was wonderfully smooth in the aspect of how it did PSOs. And we actually never had the opportunity to ask how you did it. And would those learnings from that apply to also how you do PSOs on UE5? Because we see a lot of console projects come to PC, for example, and you have like a half an hour wait at the beginning, or, you know, maybe they're using a lot of CPU in the background to asynchronously crunch all that. How would you do it? How do you do it?
Well, for RedEngine, basically everything is async. There's no blockers, so we basically kick the process, and we just don't show the object until it's ready. When it's ready, we dissolve in, so it seems like a smooth transition in. There is, if you really look, there might be some popping, because we just don't show it. We just wait until it's finished, then we attach the render proxy to the scene, and there we go. And I think that on Unreal, similar strategy can be done, right?
Yeah, exactly. That's what we're doing now as one of the options if you want to not render your objects.
Mm-hmm. But you wouldn't, like, for example, id Software kind of notoriously limits essentially their artists to a certain specific pool of shaders to keep things down. Would CDPR instead have like a more, I would say, a greater pool of shaders that can just be made by any artist that they want, or do you keep things a little bit more limited?
Oh man, it's so different now, because we went from
No, it's hard to answer that.
yeah, it's hard.
That's a hard one.
This
Yeah, okay.
Yeah.
But those are two different problem spaces you describe essentially, right?
Yeah,
one
yeah.
is like very limited, known set of PSOs, and the other one is like full artistic freedom. Do whatever you want, and then drop the problem on the engine.
Yeah. So, well, stay tuned for that one. You already answered this question, so I guess my last question to everyone here would be, as part of this entire process of making this long journey to this demo coming out, what is something you're particularly happy about, proud of, or you enjoyed during the experience? It can even just be like a moment or something like that.
I think I said it already, but for me it was the first time we saw the whole forest come into light again, because we work, me and Yannick, like I'd say that it was quite stressful, let's say, to figure out how to make this forest. And then when the Epic guys, they also work extremely hard to figure out these problems. And I think the first time I saw like in full bloom, I was like, okay, we got it. And again, as I said, the forest is super important for this game. You want the player to want to explore the forest and be hunting monsters. Okay, CT of course is important, but the forest is one of the key experience. So for me, it was like, okay, we got it. Like I was like my stress level reduced, let's just say, when I saw it.
Yeah, probably I won't be original here, because I agree. To me, the biggest concern I had visually, artistically, was actually the forest, and having a dynamic, and having the really interesting, coherent fidelity across. Because naturally you see more and more details in assets. You see already in demos, and artists are doing it daily using Unreal. They can provide an amazing assets or small worlds with Unreal already for quite some time. But having all that and a really dense, rich, and dynamic forest was something that I haven't seen before. And that was our ambition for the game. You actually want to feel the environment there, you're going to feel it. So once I saw that moving and lit, I felt like, yeah, now we're onto something.
I think you're onto something here, because when you look at the pictures, we do not want it to be static. It should not be just like a screenshot. It has to be always. And this is where the challenge was.
And exactly, if you look at the demo one more time, guys, carefully, you'll see that we try to move pretty much all the elements on the screen. So you asked today, casually, are the clouds volumetric at the background? Yeah, they are, because they need to move, and they need to react to the light and day-night cycle. And all those decisions add up to fully dynamic world. And when you think about dynamic world and dense world and then lit world, these are not easy elements to combine. And so for me, I'm an art director, but for me, actually having technically resolved the world foundation to create a dynamic, lit, believable, immersive world was a massive milestone for us, I guess.
Yeah, obviously the foliage is a highlight, but to try to be a little original here and not just copy, towards the end of a demo when things are just coming together, like everything, magical. Seeing it on the big stage for the first time,
goosebumps.
Yeah, it's crazy. I mean, very different experience for sure. So much more detail, so much more vivid, and the fact that I think you mentioned flawless before. there are some little some little snags here and there, but it really holds up really well, and that, yeah, it's just nice to look at.
Yeah, I had more time to think about my answer. So, no, like, first of all, I would say that cooperation with Epic was great because, like, I think we are quite ambitious group of people here in CD Projekt, and it was great to meet quite ambitious group of people at Epic and work on something together. So that was great to meet these people and see how they think, how they operate, how they work on the features, and like how we managed to work on the demo together. And as for the demo, what I'm proud of and what I'm happy about is actually that the whole flow, actually what Janek started to say about, like, we used context of The Witcher 4, so we were able to push the technology to its limits, and we were able to have a flow that has both, like, shows the ambition and art direction of our project, but also showcases the technology. So how these all puzzles came together and how whole flow of the demo works. I'm pretty proud of it, and yeah, like, I haven't seen it on the big screen because I was looking at the small one on which I was playing, but yeah, like, during one of rehearsals, also seeing that was amazing.
Yeah, I think I have, like, there were many good moments and many happy days. There was some challenging as well, obviously. But I think one of the best ones for me is when we were actually on the optimization phase of the project. So, like, content was pretty much locked, right? And there was, like, some passes and some great minds on both sides, like, daily actually meeting to figure out perf, and of course performance testing. And you know, with this change paradigm that we're using DRS, we are more fighting from actually, like, the frame rate was stable for a while. You're more fighting to get into resolution, and we had the one performance run after this entire, like, after a few of the optimization passes, and actually we realized, like, oh, our average rendering resolution is above the target we set for ourselves. I was like, very, very happy days. It's like, you know, because, you know, you always have those hotspots and those difficult scenes and those difficult cuts, right? So we're fighting very hard to get those really to the target, not like drop below the target. Of course, we are sometimes below the target. We assume that on average we are higher, and then you see this, and that results in, for example, like, big chunks of demo running above 1K, almost 180, right? So that was super happy. Second favorite moment, when we are, like, super close, I think was on the final rehearsals or something like that, we're setting everything up, and was, like, really spirit of partnership. Like, it felt absolutely like one team as an Epic Games, right? So, like, we're working in the same room, we're setting this up in the same room, we're sitting on the same, let's say, part of the audience. So that was, like, really, really good feeling, and I'm super happy about how this went through.
Well, I'm also grateful to have seen it live here in the studio today, played in person. You did a wonderful job. It was the controller was connected. I saw it, everyone. And it was a fantastic demo with great sound, too, something we didn't even talk about today, but wonderful sound mix there, too. So everyone, thank you so much for talking to me.
Thank you.
Yeah, and I'll hand this off to my future self. Thank you, Alex from the past, and this is just me at the end of the video saying thank you for tuning in and listening, and thank you to CDPR for hosting me in Warsaw there. And if you did like the video interview, please hit that like button, subscribe to the channel, ring the little bell, help us out on Patreon. And as always, this is Alex, bin you farewell und auf Wiedersehen.